carbon. So if you add just one branch on the second carbon, now to complete the valency of the carbon, you can add the hydrogen atoms. Now the longest chain, this longest chain is propanoic acid, but there is another branch which is attached on the second carbon. So you can say this is not only the propanoic acid, but CH3 group is also attached. So this is 2-methyl propanoic acid. This is 2-methyl propanoic acid. If you want to add one more methyl group, you have to rub this hydrogen. So if you rub this hydrogen, you can add one more methyl because carbon can make 4 covalent bond. And if you keep this hydrogen and you add CH3, definitely the carbon must be, then the carbon will become pentavalent. And you have to keep the carbon as a tetravalent element. Now, this is the second carbon and this contains 2-methyl group. So now this compound is 2,2-dimethyl propanoic acid. Let me add here the first compound of this series, HCOOH, which is methanoic acid. Now, if we count the number of carbon, hydrogen, and oxygen, I will get the molecular formula. Like there are 3 elements in each carboxylic acid. Okay, there is 1 carbon, 2 hydrogen, and 2 oxygen. All contains 2 oxygen, so you can write O2, O2, O2. Just count the carbon atom. There are 2 carbon now and 4 hydrogen. Now there are 3 carbon and 3, 5, and then 6 hydrogen. There are 4 carbon and 3, 4, 5, 6, 7, 8 hydrogen. So if you look at the molecular formulas of these carboxylic acid, you can deduce the general formula, which is, now look at the ratio of the carbon, hydrogen, and oxygen. There are always 2 oxygen atoms, so you can write O2. Oxygen will never change. Now, the ratio of the carbon and hydrogen is, if carbon is 1, then hydrogen 2. If carbon is 2, hydrogen 4. And if carbon is N, hydrogen must be 2N. Mean the ratio of the carbon and hydrogen is 1:2. The hydrogen must be double as compared to the carbon. So this is the general formula of the homologous series of carboxylic acid. The next type of the organic compounds are esters. Esters are the sweet smelling compounds. They have the functional group COO, CO2, or C double bond OO. So these are the three different ways to represent the esters. So this suffix for the esters is NO8. All organic compounds which contains NO8 as the ending part, those are esters like methyl propanoate, ethyl ethanoate, butyl methanoate. So any organic compound which contains NO8 as an ending code or suffix, those are esters. Let me draw ester. So if you want to draw any type of ester, just start from the center. Okay, now this is the central part of the ester. Now you can extend the ester on both sides. I mean, you can extend the ester on the side of the carbon as well as on the side of the oxygen. You can attach the hydrogen on the side of the carbon, but you can't add hydrogen on the side of oxygen. Now, this oxygen is already bivalent. You can't add more hydrogen or the carbon with this oxygen, but you can add or you can attach some more carbon on this side, I mean with this oxygen, but you can't add hydrogen. If you add hydrogen, just look at this. If you add hydrogen, this is not a ester. This is carboxylic acid. So that's why always keep in your mind that you can't add hydrogen with this oxygen. Nothing can be attached with this oxygen. This is already bivalent. Now let me remove this hydrogen. This is not ester if you add this hydrogen. Now, if I add hydrogen here, this is okay. And then you will have to add some carbon because you can't add hydrogen. Let's see if I add hydrogen. Now, what do you think? Either this is the ester, this is not ester. Because if you add hydrogen, COOH is the carboxylic acid. So this is the displayed formula of methanoic acid. So let's remove the hydrogen. So if I remove the hydrogen and if I add the carbon instead of hydrogen, now it's okay. Now you can make the carbon tetravalent CH3. Now to name this ester, first of all, just look at this part. The carbon which is attached with this single bonded oxygen. It may be like this, or it may be like this. Okay, if I add hydrogen and if I add CH3. So just keep the eye on the single bonded oxygen, the oxygen which contains two single covalent bonds. Now, this part actually comes from alcohol, and this part from carboxylic acid. So if you want to make the ester, alcohol and carboxylic acid, they can react with each other to form ester. Because now at this moment we're talking about the nomenclature, so that's why I'm going to tell you the names of the different types of ester. Now, first of all, look at the number of carbon atoms which are attached with the single bonded oxygen. Either your organic compound is in this form or in this form. How many carbon atoms are attached? Just one. As